Let's talk about trig identities of half angles. So trig identities of half angles. Now, as usual, there are basically three. You can always make all six, but the basic three are the sine. I'm going to put theta over 2. Sometimes they use capital A or whatever in some books. The sine of theta over 2 is equal to plus or minus, and you have to determine that based on the value of the angle, the square root of 1 minus the cosine of theta all over 2. The cosine of theta over 2 is equal to plus or minus the square root of 1 plus the cosine of theta over 2. And the tangent of theta over 2, and there are many, many versions of this one, but I'm going to take one that's really obvious based on sine and cosine. You know that sine divided by cosine is equal to tangent. So let me take this. It is plus or minus from these. They don't cancel each other out necessarily. And then we've got this one on top, this one on bottom. So we've got this. We've got 1 minus the cosine of theta over 2, and this one is the square root of 1 plus the cosine of theta all over 2. Well, if we take the reciprocal and multiply, we get plus or minus the square root of, this is 1 minus the cosine of theta all over 2, and then this one is the reciprocal here, 2 over 1 plus the cosine of theta. So these cancel because they're both under square roots, and you can put them all under the same square root, which is not usually appropriate because it's not rational, but sometimes people do this. 1 minus the cosine of theta over 1 plus the cosine of theta. Now, if you want to rationalize it, you could multiply both sides. Notice this is the whole square root, so I'm not going to do conjugates. The whole thing's a square root, so I'm going to just multiply by on top and bottom by 1 plus cosine theta, 1 plus cosine theta. And here we've got this. We've got the square root on top here. We've got 1 times 1 is 1. Minus cosine theta plus cosine theta. That drops out. So we've got minus cosine squared of theta. And then here we've got 1 plus cosine theta because it's a square root times a square root. Now, not only that, but, and I missed the plus or minus, not only that, but sine squared plus cosine squared equals 1. So 1 minus cosine squared is equal to sine squared. So here's what you've got. You've got the square root of the sine squared of theta all over 1 plus the cosine of theta, or plus or minus the sine of theta over 1 plus the cosine of theta. So that's kind of slick. Works out pretty well. Okay, let's try to find a value. Now let's find one that's super obvious and see how we can do this. Let's take this sine of 60 degrees over 2. Okay, so let's do that. The sine of 60 over 2. Now, that is not a common one to do just because you ought to know the sine of 60 over 2 by heart. The sine of 30 degrees is equal to 1/2, all right? But let's pretend like we don't know it and check it out. So if I use the formula for sine of something over 2, this is theta. So I'm going to do that. So I get this is plus or minus the square root of 1 minus the cosine of 60, and then it's all over 2, okay? So now we've got to work this, and we've got to decide whether it's plus or minus also, but this is going to be the square root of 1 minus, what's the cosine of 60? It's 1/2. And this is over 2. So this is plus or minus the square root of 1/2 over 2. 1/2 divided by 2 is 1/4. The square root of 1/4 is 1/2. Now the last thing we need to do is look at this. Sine of 60 over 2 is sine of 30. 30 degrees is in quadrant number 1. All functions in quadrant number 1 are positive, so this one's positive. So we use the positive version. Now, do you do that for 30 degrees? No, you do not. But what if you needed to find something like the tangent of 22.5 degrees? Now, I know I'm working in degrees. You might want to work in radians. Works just fine. But if I needed the tangent of 22.5 degrees, that is the tangent of 45 over 2, okay? So if I needed the exact value for that, and it's not going to look nice, I'll warn you right away. But if I needed that, I could use one of these versions of tangent up here. Theta is 45. So let's use this one. So let's let this be theta. And so our answer is going to be plus or minus. Now tangent of 22.5, that's in quadrant 1, so the tangent's positive. So that is going to be plus the sine of 45 divided by 1 plus the cosine of 45. Well, the sine of 45 is square root of 2 over 2. This one is 1 plus the square root of 2 over 2. Cosine of 45 is square root of 2 over 2 also. So if I multiply by 2 here and by 2 here, that's going to cancel that. I will have square root of 2. Down here I'm going to have 2 times 1 is 2 plus square root of 2. Now 2 plus square root of 2 in the denominator, not terribly good, so let's rationalize. We have the square root of 2 over 2 plus the square root of 2 multiplied by the conjugate. That's a good way to rationalize. So now we've got to multiply here, 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 here. This times this is 2 square roots of 2 minus square root of 2 times square root of 2 is 2. Here we have 2 times 2 is 4. We have 2 times minus square root of 2 and 2 times plus square root of 2. Those add up to 0. And then square root of 2 times minus square root of 2 is minus 2. So we have this. We've got 2 times the square root of 2 minus 2 all over 2. Or, let's factor. Got square root of 2 minus 1. Took 2 out of that and 2 out of this. So our answer is square root of 2 minus 1. Works pretty well. All right.